Welcome to the 12th video in this video series of using Godot and the Rider IDE and C# to create and modify a 3D mesh. In our last video, we went through a bit of interesting math to allow us to be able to click on the cube here and to have the triangles highlight themselves in purple, depending on whether they're facing us. And this video is going to I found an issue with an assumption I was making that will break what we did here, but the fix is actually pretty simple. If you remember from the last video, I spent I spent a very large amount of time covering the difference between global and local coordinate space, and that's what nabbed me here with this problem. And this problem is really easy to show. So if we go ahead to our cube and we rotate the cube, let's say by 90 degrees, and then 90 degrees on the y-axis, and then we try to run the game, and then we try to click around, we'll notice, click, well wait, it's not highlighted. What's going on here? Let's click here. Wait a minute, that's not working. What about if I click here? Well, wait a minute, you got a purple triangle there. What's going on here? This isn't, I'm clicking and you're not working. Well, the problem is when I was using the surface normals, remember we were doing that math to compute the purple arrow and the surface normals to get an angle, and the surface normals are these white lines. Well, if we go to our code and Rider, we're going to see that we were very careful about making sure that like the triangle vertices were moved to global space. But the problem is when we were checking the angle, you notice here that the face normal we're getting from the mesh data tool, we're not converting that to the global coordinate space, so it's still working, it's still using the local coordinate space. And the reason it works when it's not rotated is because, well, when we don't rotate the cube, the global and local space are mostly the same. Remember, we lifted the cube up a little bit, but we didn't rotate it, so the normals would still be facing in the right direction. But as soon as we rotate the cube, well, now the global space and the local space aren't the same, and so it doesn't work when you rotate the cube. Now, the fix is really simple. So we just need to make sure that when we are computing the angle between the test vector, which is the purple arrow, and the current face normal, that the face normal is actually in world coordinate space, global coordinate space. So that's really simple to do. If we just, let's put this on a different line. Remember we said that the way we converted the triangle from the mesh's triangle from local to global coordinate space is the cube mesh instance knows how to convert stuff to global space. Well, that's all we have to do here. So if we just do a cube mesh instance and we do a to global here, and we just send in this thing, that'll fix it. So basically we're taking the face normal, we're converting it to global space, then we're computing the angle with the purple arrow in it, and then everything should line up. So now if we run the game, we should be able to see that our game works like it did before, even with the cube rotated 90 degrees. Bam, bam, bam. So everything's working even though it's converted 90 degrees. Or rotated 90 degrees. So then that kind of had me panicking a little bit, and I'm like, well, you know, it seems to be working, but did I make a bad assumption about this static body? Because if you remember, when let's go back to Rider, we're sending in this this hit vector into this get hit mesh triangle face index method, and up here, what we're sending in, this click position, is coming in from this click position parameter of the input event on the static body. And so I was like, oh my gosh, you know, it seems to be coincidentally working, but is that also a problem? Well, I looked in the documentation, and if you go to the static body and you'd have to go up the hierarchy to get to collision object to find that method. But then if you go to input event here, it says accepts unhandled input events. Click position is the click location in world space. So, it's already in global space. And I guess just to make sure terminology, sometimes you'll see things, maybe not in Godot, but just in 3D. Like when they say world coordinates and global coordinates, those are the same thing. And then sometimes you'll hear local coordinates or object coordinates, and those are the same thing to each other. So just the terminology. I think Godot has been consistent about calling it world. I call it global. Well, actually, I take that back. I don't think they are consistent, because if this says world space, but the method we called down here was to global, apparently they're also using global and world kind of interchangeably. Maybe I'm misunderstanding, but as far as I can tell, the terminology world and global mean the same thing. Those two things are the synonymous, and then object and local, those two are synonymous. And if we wanted to test this just to make sure, so you noticed here that let's un-90 this just to put it back where it was. So you'll notice, like when we were clicking, this is the, let's go back to writer so we know what we're doing. So when we were clicking on the in the cube, the static body, this is the line that's being printed, and it's coming in from that click position. You clicked at point, click position. And then if you look down here, you'll see that these numbers are between 1 and like 3, because remember we lifted up the cube like 1.356. So an easy way to test this is, let's take the cube and let's just translate it up. Let's translate it up 10, so it'll be 10.356. And then let's just take the camera and then let's translate that up 10, so it'll be 13. And let's run the game. And so the way we're going to test this is when we click, we would expect to see numbers like 13 or whatever. So you'll notice here the Y value is 10.87, 10.38. So that's how we know that we're confirming to ourselves that what the documentation said, that the click position we are getting from that static body callback is indeed in world/global coordinate space already. So I just wanted to make sure of that, because as soon as I found when I rotated the cube that I forgot to turn the normals into global coordinates, I started panicking, going, oh my gosh, did I forget the static body too? And I honestly didn't know. Let's put this back to where it was. I didn't know if it was returning back global or local space, but it turns out it is global, and so that works perfectly for our I guess I didn't quite, well, never mind. So I put this back the way it was. So anyway, I just wanted to make sure, it's a quick video here, but I wanted to make sure we fix that, because taking the cube and rotating it, I wanted to make sure that no matter which way this cube was rotated, that the click was going to work. And bam, 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 it does now. So just by that little simple change there, that just by making sure we're in the global space, that fixed it. It's kind of funny, because the last video, I mean, I spent, some could argue, way too much time like beating that point, into the video, that global and local, and it turns out that I didn't listen to my own warnings because I forgot to do it myself. So anyway, I'm going to end the video here, and hope to see you soon. Take care.